Black holes, with their immense gravitational force capable of bending and capturing light, are some of the most powerful entities in the universe. Nothing, not even light, can escape their grasp. These enigmatic objects are scattered throughout our galaxy, including a supermassive black hole at the Milky Way's center, which is about 4 million times the mass of our Sun. Scientists continue to delve into the mysteries of how black holes are formed and how they interact with the cosmos around them. In the course of this research, they have stumbled upon a chilling discovery that could potentially redefine our understanding of the universe. Join us as we explore the complex nature of black holes and their potential implications for humanity's future. To grasp the significance of this discovery, we first need to understand the fundamental nature of black holes. What exactly is a black hole? These are cosmic puzzles that have fascinated both scientists and regular folks. According to Einstein's theory of relativity, time is the fourth dimension, intertwined with space. Gravity, in this theory, is not a push or pull force, but a bending of space and time caused by mass. Imagine a trampoline surface with a bowling ball on it. The ball makes the surface sag, pulling smaller things into the dip. With black holes, which have infinite density, they create a deep and dark hole in space-time that's really hard to understand. Scientists are still figuring out where matter goes when it's pulled into these mysterious and super strong force fields. But the basic idea is that, similar to the trampoline, everything gets pulled into a deep and dark space. The mysterious concept of black holes got its name in 1967, but the idea has been around since 1783. John Michell, considered the father of black hole theory, suggested that even though black holes are invisible, we might detect their intense gravity fields if they have stars orbiting around them. Others expanded on this, and by the 1930s, theorists using Einstein's theory showed that really massive stars could collapse under their own gravity and become black holes. Mitchell's prediction was confirmed in the early 1970s when astronomers Louise Webster, Paul Murden, and Thomas Bolton observed a massive but invisible object orbiting a blue star 6,000 light-years away. They called it Cygnus X1, marking the first identified black hole. This discovery showed that, even though we can't see them like stars, these mysterious objects can indeed be detected. The science behind black holes is mind-blowing. We not only know that there might be around 400 million of them in our Milky Way, but also that at least 2 trillion galaxies in the observable universe have supermassive black holes at their center. This means that areas of space containing multiple galaxies could have hundreds or even thousands of these supermassive black holes. The sheer power held within these mysterious objects raises questions about what other secrets they might hide. Black holes are real. Once considered just a theory, we now have proof they exist, thanks to a groundbreaking effort called the Event Horizon Telescope. This collaboration of 8 telescopes snapped the first ever image of a black hole, giving us a look at something that was once thought unseeable. Imagine pointing cameras from different places on Earth toward a distant galaxy called Messier M87, which is about 55 million light-years away. They captured an astonishing picture of a supermassive black hole sitting at the center, surrounded by a spinning mass of extremely hot dust and gas called an accretion disk. The dark part in the center is the shadow of the black hole, caused by its powerful gravity that even traps light itself. This image, a result of capturing radiation from incredibly hot matter, holds a wealth of information. Now, are black holes actually holes in space? The popular idea is that they're holes or gateways leading to other places, often linked to the concept of wormholes. Wormholes are like tunnels in space-time that might let us travel huge distances instantly. However, while this idea was proposed by scientists long ago, it's doubtful that they exist naturally or would stay stable enough for practical use. Even if they did exist, they'd probably be too tiny for anything more than a single particle to pass through. So, these kinds of portals are unlikely to be formed by natural black holes. This misconception might come from movies and stories that depict black holes as pathways for time travel. But in reality, a black hole isn't a hole at all. It's an object in space with an incredibly strong gravitational pull. The term hole is used because it sucks everything in without letting it escape. But it's essential to know that what goes in doesn't come back out, giving it that hole-like quality. In simple terms, it's a super powerful object that warps space and pulls everything toward it. So what would really happen if you fell inside a black hole? Imagine a black hole as a kind of dark, impenetrable disk from the outside. However, Once you pass its event horizon, the point of no return, the darkness starts to change. Light from outside the event horizon bends and distorts, creating a strange glow within. Even though the exterior seems pitch black, the inside of a black hole can be surprisingly bright. It's like looking through a one-way window, where you can see the universe beyond the black hole's boundary. As you continue to fall into the black hole, you can observe the universe through this unusual window. You'll witness the light from galaxies streaming in and observe the effects of exploding stars over thousands, millions, or even billions of years. But here's the catch: there's no way to stop your descent. The black hole's throat narrows, capturing all the light and creating a bright tunnel-like effect. Now remember the saying, light at the end of the tunnel? Well, in this case, that light is a sign that there's no hope. According to the theory of relativity, as you fall towards the black hole's center, you'll experience extreme stretching, crushing, and breaking into pieces. The intense gravity at the heart of the black hole warps space-time, leading to a point known as a singularity, where all paths converge. As you get closer to this singularity, the powerful forces of gravity and motion will batter and destroy you. Eventually, your atoms will be torn apart and scattered across the singularity, leaving behind nothing but empty space. This whole process intensifies the concept of black holes as infinite beings of nothingness, often referred to as singularity. What is the mysterious singularity at the heart of a black hole? Well, it's a puzzling concept in physics, and it represents a point where matter is squished into an incredibly small space, way tinier than we can imagine using our regular ideas of time and space. Scientists are quite sure it exists, but they're not entirely sure what it really is or how it comes to be. Some theories suggest that it transforms into a different kind of matter or energy, but there's more to consider. Is the whole singularity idea maybe not entirely accurate? Some scientists propose that deep within black holes, matter doesn't get compressed into an infinitely tiny point, but instead takes on the smallest possible form it can. This idea introduces the concept of a Planck star, a theoretical notion from the world of loop quantum gravity. According to this theory, space and time are not smooth, but are made up of tiny, discrete pieces at an incredibly small scale, making our universe granular and quantized. Supporters of this idea believe it could help explain gravity in a more natural way and prevent singularities from forming inside black holes. In simpler terms, as matter collapses under the immense pressure of a collapsing star, it might interact with these tiny, chunky pieces of space-time, creating a ball of matter that is much smaller than what we'd expect from a singularity, but never reaching the point of being infinitely small. So, in this view, things could exist beyond a singularity, and the entire black hole might just be a temporary blip in the grand scheme of the universe. Black holes are truly fascinating entities in the universe, captivating scientists with their mysterious nature. One key aspect that adds to their intrigue is the event horizon, a boundary connected to the mass of the black hole. Essentially, the larger the black hole, the bigger its event horizon. Despite gradually losing mass due to Hawking radiation, black holes persist for incredibly long periods, ranging from millions to even billions of years. As they lose mass and their event horizons shrink, the black hole's interior maintains an infinite density, preventing any further collapse. This enduring existence allows black holes to carry ancient secrets, as evidenced by recent astronomical discoveries. Researchers have identified 6 ancient galaxies surrounding a supermassive black hole from the early stages of the universe. This finding offers valuable insights into the formation and growth of supermassive black holes during the universe's infancy. It supports the theory that these black holes can rapidly expand within extensive web-like structures filled with gas. While this discovery has sparked excitement among scientists, questions about the rapid growth of black holes within large gas webs in the early universe still linger. Driven by a desire to uncover more about these mysterious cosmic objects, scientists have delved deeper into their exploration. Utilizing the European Southern Observatory's Very Large Telescope, astronomers have observed several galaxies encircling a supermassive black hole. These galaxies are embedded within an expansive cosmic spider's web of gas, extending more than 300 times the size of the Milky Way. Black holes, these mysterious and captivating cosmic entities, are believed to have originated from the collapse of the earliest stars in the universe. Scientists think that these black holes grew rapidly, reaching enormous masses within the first 900 million years of the universe. The challenge, however, has been explaining how they could accumulate enough material to achieve such remarkable growth. A recent discovery of a web-like structure composed of galaxies offers a potential solution to this puzzle. This cosmic spider's web is filled with gas, potentially providing the necessary fuel for the central black holes to become supermassive giants swiftly. While more research is needed to confirm this idea, the finding presents an exciting new perspective on the formation and evolution of black holes. Contrary to popular belief, black holes are not always positioned at the center of a universe. They form when stars collapse under their own gravity, creating incredibly dense objects with powerful gravitational pulls. Most galaxies, including our Milky Way, likely contain at least one central black hole, but some galaxies may have multiple black holes. These cosmic entities can be identified by their impact on their surroundings, emitting substantial radiation or bending light from distant stars. Additionally, smaller black holes, known as stellar mass black holes, may exist throughout galaxies, formed when stars collapse. So, black holes are not restricted to specific locations. They could be scattered anywhere across the vastness of space. Moreover, black holes come in various sizes, not just the gigantic ones. There is evidence suggesting the existence of smaller black holes. Therefore, the vast expanse of space serves as a diverse and extensive habitat for black holes of different sizes and characteristics. In October 2018, something really intense happened in a galaxy 665 million light-years away from us. A small star got too close to a black hole and got torn apart in a big way. Scientists call this a tidal disruption event, or TDE. This isn't new, but recently something surprising happened. The same black hole woke up again and started shooting stuff out super fast, almost as fast as light, straight toward Earth. This is a big deal because it goes against what we thought about black holes. Normally, things get sucked into a black hole and never come back out. But this time, it's like the black hole is spitting things out instead of swallowing them up. Most TDEs shoot stuff out really fast, but this one is different because it's doing it more slowly and steadily. This makes scientists think that after a black hole eats a star, it might take some time before it throws stuff back out. The tricky part is that there could be black holes out there holding onto things from way back, and one day they might spit it all out. The stuff they shoot out could reach Earth and cause really big problems. It's hard to know what's going to happen exactly, but it's something scientists are keeping an eye on. And that's all for today's video. What do you think? Could this affect Earth? Tell us in the comments below. If you like this, give it a thumbs up, and remember to subscribe to our channel for more updates like this. See you next time.